Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 18th February 2023. The problem statement for today is Apple sequences. This problem is based on two-pointer algorithm and this question has been asked in Ola Caps interview. Let's now open this problem. First we will go through the problem statement. Here it says there is a string of size n containing only A and O, both are in caps. A stands for apple and O stands for oranges. We have m number of spells. Each spell allows us to convert an orange to an apple. Okay, so here it is saying we will be given a string that contains A and O, and we will be given some spells. In each spell we can convert an orange into an apple. Find the longest sequence of apples you can make given a string and a value of m. So m is the number of spells. Okay, so let's go through the example first. Here it says n is equal to 5, m is equal to 1. So number of spell is 1. That means only one conversion from orange to apple is allowed. And this is that string which is given to us, AAOAO. Here the output it says is 4. Changing the orange at third position into an apple gives us the maximum possible answer. So if here we have one spell, so we can convert one orange to an apple. So if we decide to choose this one, then this O will become A. So after conversion, this O will become A and O. So this O will become A. So, and we need to find the longest sequence of apples which we can make. So after this is getting converted to A, we can see there are four apples. Those are in sequence. That means the number of apples are 4. So now let's go to the second example. Here it says n is equal to 5, m is equal to 1. So here also one conversion is allowed. Here m is array is AOO. Here output is 2. Changing any orange into an apple gives us the sequence of length 2. So here if we change any O, if you pick any O and convert to A, then we can see the maximum sequence that we will get of apples will be 2 only. So here what we will do, here we will try to use sliding window approach to solve this problem. So in this one I'll try to initialize two variables saying left and right, which will be defining the boundaries of the current window. It will also here we will also initialize a counter that we'll calling as number of zeros, the number of zeros, or number of O's, to count the number of oranges in the current window. And while iterating over the loop, we will be iterating it through the right pointer, and whenever we find an O is there, so we will increment the counter of number of O's. And if in any case we see that number of O's exceeds m, then in the while loop, inner while loop, so we will increment the left counter. We will increment the left pointer to shrink the window size by one character at a time until the number of oranges in the window is less than or equal to m. For each iteration of that loop there, the code will calculate the length of the current window as right minus length plus 1. That means right boundary of the window minus length plus 1. And we will update the max length variable, which will be holding the maximum sequence we have seen so far. Okay, so here if we try to understand this through this one, so here initially both a left and right pointer will be pointing to A. So as and when we start iterating over this loop, left will still be here, but right will be moving towards right. So here first we will encounter this A. We will increment the counter of the maximum length by 1. Here also 1. Here also it will be incremented by 1. Here so the value will be 2. here, if you see in this example, then the maximum number of that means the flips allowed or the spells allowed was 1. So just consider that this has been converted to A. Since we are allowed to convert one O to A, so this we will consider that if we are utilizing that opportunity of converting this A, so now even this will be part of the sequence of the longest sequence of apples. So here it will be 3. Here also, here A is there, so it will be 4. But when it reaches this next one, so here the number of O's, that means number of oranges oranges we have got, that is 2. So here what we can do, here we will stop our right pointer here and we will increment the left pointer, which was still pointing to this first index. We will start incrementing that one and we'll see where that O is present, so that from that location we will start considering for our next sequence. I hope this is very clear. So based on this approach only, let's start coding for this. So here whatever we have discussed in the logic, that only we will write here. We will write here int left is equal to 0. Sorry, let's issue all in small. Int left is equal to 0. Int right is equal to 0. We are using here 2 pointer algorithm. That means left and right will be 2 boundaries of the window. And here number of O's, that means number of oranges, everything even this will be 0 initially, and the variable which will hold the return type, that means the maximum length of oranges, that sequence, even that is 0. Okay, so now here what we will do, here as we have discussed, we'll write while loop till the point right is less than array dot length of, or you can directly use even n, either thing is fine. So here keeping the left still at this A, keeping the left still at A, we will start playing with the right counter, that means right pointer, and we just keep on incrementing this. And what we will check, if right pointer has encountered any O. So array dot caret right is equal to O. If this is done, then what we'll do, we'll increment the number of O's, that number of oranges, 2 plus 1. So this is done. That means whenever we are encountering this one, and here we will check at each moment, whenever this orange is encountered, we will check what is that count. Has it exceeded the number of M, that means the number of spells given? So for that we'll check if it is greater than M, the number of spells given, that means we are allowed only M number of flips, that means M number of substitution from oranges to apples. So we can bear only up to given M, but if anything is exceeding after that one, then we will increment the, so here this is then we will start checking for the left pointer. We will start moving left pointer, saying that a dot caret of left, if it is encountering a 0, that means not 0, O, then what we can do, we can subtract number of oranges we have found. So here we started with the right one until the point, if at any point we see that number of oranges is greater than number of M, that means number of substitution allowed. So it will be in this case. So here we will start incrementing. So here we will check if here we will start moving the left pointer, and we will check if this left pointer is encountering a 0 or not, so that means an orange or not. So after reaching to this point, left pointer will encounter a orange. So now next window will start from this left side, from here onwards, from this onward, and each at each step, just a minute. And each step here, once this we will decrement this, we'll just increment the counter plus plus. So even if see, for first two scenarios, that means A and A, this O is not encountered. In that case, it will simply increment left window, and right pointer will be waiting at this moment. Okay. So now this is, once this is done, then here it will just try to calculate math dot max of max len, and here max len or right minus left plus 1, and this will assign it back to max len, max length, and here we'll just increment the right pointer so that we can track with the next character in the string. So once this is done, then here it will simply return max len. I'll try to explain it again, entire thing. So our left and right will be pointing to the starting of this A. So here it will check whether right is less than the length of the string. That is correct. Okay. So here it will check if array dot caret right is equal to O. So when right is 0, so here it is A, it's not O. So what it will do, it will skip this part. Here the number of O's will be 0, so it will skip this part as well, because since this increment has not happened, it will skip this part. So it will directly come and check. That means from this one it will directly come and check math dot max of max len it was 0, and right minus left plus 1. Right was also 0, left is also 0, but plus 1. So here we are just checking, here the max len will be plus 1. So for that only I explained here initially that till this O is encountered, we will simply increment the right counter here, and we'll just keep checking what is that maximum sequence of O we have, maximum sequence of A, that means apples we have got till now. So that will be calculating from this one. So once this is done, so the max length is 1 now. After that, this increment is done, it will again check. Now right here it will be 1. Earlier it will be 0, now it will be 1. So 1 less than array of length. Yes, it is still less than 0. Less than the string length. So it will again check that at position 1, do we have orange? Still we have not got orange for this one, because here still here it is apple only. Here again also it will skip this part. Here it will again check. Max length was 1 previously. Now it will check right was right after increment it has become 1. 1 minus 0 plus 1, so it will be 2. So now the max length will be 2 here. Once we encounter this for the next iteration of right, once we encounter this 0, so that time we will increment this number of, sorry, it's not 0, it's O. We will just increment the number of O's here. Here it will be number of O's here. So number of O's will become 1. Is it greater than the number of spells, that is M? No, it is still not greater. It is still not greater than. It is equal to the number of M. That means that many conversion we are allowed to do. So we will just assume, and we will just convert that. We will assume that even this O is converted to A. So even this is not done because it is not greater than. Now here again it will check max len was 2. From the previous step it was 2. Now right is 2, 2 minus 0 plus 1, it will become 3. So that way we'll continue, and once we get a O where the counter of O will be greater than M, so we have to now look for the next window size, so that we can get the different alternatives of the maximum sequence of apples allowed. So now with this, now let's try compiling the code. So here you can see we have got our output as 4, that is correct one. Now let's try submitting the solution. So here we can see we have got all the test cases passed. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.